Hello everyone, my name is Evangelos Lamprou, and this is a presentation of the work conducted by Professor Christos Fidas and me, entitled Investigating Applicability Heuristics of Associated Programming in Game Development, Use Cases and Empirical Study. The overview of this presentation is that we will start off by giving a problem statement, some examples of this problem that we're trying to solve, explain how associated programming is different than traditional imperative programming, show some related work, explain our proposal, and then present some case studies we implemented, as well as the results of the user study. And finally, we discuss some conclusions. The problem we're trying to solve is that software engineering is hard. So what if AI code or specific parts of a game's code could be placed in modules separate from the rest of the game's logic? And implementing algorithms is also hard. So what if some parts of game logic could be written in a more expressive or higher level language? An example is that you imagine you're a game developer and you want to create a character that needs to find the optimal path between points A and B. A common approach would be to use the A-star algorithm. However, even in this common scenario, for this kind of implementation, someone needs to have a solid background in both algorithms and data structures, and needs to spend a significant amount of time in order to correctly implement this algorithm. What this results in is that in small independent game development teams, the role of programmer and designer are often done by the same person. So the creative process of coming up with a new game mechanic needs to be interrupted in order to do some kind of complex implementation, to try out an idea. This can really hinder creativity. So imperative programming puts the focus into the programming verb, where you need to explain to the computer a set of instructions in order to go from problem to solution. However, with declarative programming, and ASP in specific, you start off with a problem and then you go ahead and model it. This modeling, if correct, is able to be placed inside a solver, which then outputs a set of solutions. So what this results in is that programs are a lot more concise. And this is the same A-star algorithm now implemented in Klingo, which is the ASP input language we used in this project. ASP has been implemented in games in the past, for example, for creating maze generators or puzzle level generators, as well as for creating smart agents that can play complex games like Angry Birds or board games. So the goal of this research project was to create a generic framework for applying ASP to games and also present some applicability heuristics in order to help future game developers apply this methodology successfully in their projects. The heuristics we came up with were these of brevity, where only important parts of the game are actually encoded inside ASP, a relatively small solution space, which stems from the real-time constraints that games have, because we don't have the luxury of letting the solver find an optimal solutions for minutes or hours. We need to give it a small amount of options to choose from with each time step. And finally, we have emergent complexity, where interesting behavior does not come from having a complex ASP modeling, but by having simpler agents interact with each other in interesting ways, or have a set of simple rules result in interesting generation of artifacts. Integrating ASP into a game development environment is done by starting with a game world, which represents the game runtime, the set of data structures that represent the entities inside the game. These are turned into logic atoms, and together with a set of rules and constraints authored by the game developer are put inside an ASP solver. The solver outputs answer sets, and these are then integrated back into the game world as either agent behavior or artifacts, if we're talking about a generator. We also implemented some case studies And the goal of that was to show that our proposed methodology can be applied into a wide range of applications and show how our heuristics play a role in each time. So we start off with a football game where we have football players whose logic of where to move or where to kick the ball is implemented in ASP. We give them a small set of logical rules which connect actions to events, and based on that information, they are able to take the ball and move it closer to the enemy goal, and then successfully play football. Another example is that of terrain generation, where we encode the placement of tiles as an ASP program, and we give it some specific instructions like a constraint where no blue and red tiles can touch, or that a river has to flow from one side of the map to the other. We're able to give high-level constraints, which results in a generator that has a high level of controllability. Finally, we wanted to see if this proposed methodology is able to be applied and used successfully by beginner game developers. So we conducted a study with a total of 8 participants for a total of 24 hours. The sessions that we conducted were one-to-one between the participant and the researcher. All participants were comfortable with programming, but not necessarily using ASP. And because of the small number of participants, we limited ourselves to a more quantitative analysis of the study results. So the study had 3 phases: an introduction to ASP and its semantics, as well as the syntax of the Klingon language. Phase B, which is where participants chose a game mechanic that they would like to implement and did implement with the help of the researcher. And finally, a semi-structured discussion happened where we asked participants what they thought of the general framework. These are some examples of projects created during the study. And to the question of whether this methodology does provide value to game development, a lot of participants did mention that they did like that programs became more concise and that they felt more comfortable developing mechanics that were a little bit more complicated. Whether they would use ASP again in the future, participants did mention that the input language and mental model was a little bit unfamiliar to them, but they would like to try to use this framework again in the future for simpler scenarios. Ways to improve this methodology would be maybe to add some kind of visualization that shows how the ASP solver arrives at solutions. This could possibly help with debugging ASP programs, and maybe create some kind of library or abstraction layer on top of Klingon, something ready-made, specifically made for games. In conclusion, we think that ASP can indeed help with quick prototyping, since because programs are a lot shorter, changes can be made a lot faster. And since ASP offers a different programming paradigm, which can help with taking game development into new creative directions. In the future, we would like to implement some of the proposals by the participants and also apply this methodology into a longer running game development project. I'd like to thank you very much for listening to my talk. You can contact me and Professor Fidas at these emails. And also, we've made all the code and user study data openly available in a GitHub repository. Thank you very much.